Hello, welcome. We have an interesting duty or task today. We want to prove the difference of two squares, a popular identity in mathematics which we often use. We are given that x squared minus y squared equals x minus y multiplied by x plus y. We want to see if this is true. Remember, a square has equal sides. So if we have a square whose side is say, or the length of the side is x, area of such a square will be x squared. If we have a second square, and the area of the second square, or rather the length of the second square is y, area of the second square will now be y squared. Difference, don't forget, is the result of subtraction. Okay, so we are basically looking at area of a particular square, perhaps a bigger square, minus area of a smaller square. That's the concept or logic we shall use to prove this identity. So what we are going to have is that I'm going to bring a bigger square. I bring in a bigger square here. Remember, it's a square, so the sides will be of equal length. If this is x, this is x. X times x is x squared, so the area of the bigger square is going to be x squared. If I bring a smaller square inside here, okay, I call the length of this y, the sides y. So the area of the smaller square, y times y, will be what? Y squared. Have you noticed that? That means this space that is rectangular, if I say the area of the bigger square minus area of the smaller square, the difference will be this L-shaped portion. Okay, there's an L-shaped portion that is represented. I've just marked it so that you can see. Okay, so area of the bigger square minus area of the smaller square will be this L-shaped portion. Okay, so how do we get the area of this L-shaped portion? If we can get the area of this L-shaped portion, we have gotten x squared minus y squared. That is just it. So we have that x squared minus y squared. What's it going to be? So let's play. We can divide the L-shaped portion into two rectangles. Look at it here. So we have a rectangle here and a rectangle here. Now, for this rectangle, the length is x, but the width, remember, from here to here is x, while from here to here is y. So this little gap is going to be x minus y. So the width of this first rectangle will be x minus y. Take note. And then for the second rectangle, remember, from here to here, the length is y. The width again is going to be x minus y, okay? So that means this little width is nothing but what? X minus y. So we've gotten that. So let's go. What will be the area of the first rectangle? So that will be length multiplied by width, which is x minus y. Plus, remember, we need to add the two to get the area of the L shape or the L portion. What will be the length or the area rather of the second rectangle? That's going to be y multiplied by this. So that will be y multiplied by what? X minus y. Okay, so here x minus y, here x minus y. If we factor out the common term here, we can say x minus y. We can factor that out into x plus y. So remember, we were looking for x squared minus y squared. So this is nothing but what? X squared minus y squared. That's all. So that goes to show that the difference of two squares, x squared minus y squared, equals x minus y, x plus y. That's the end of our proof. QED. If you've not clicked the follow button yet, please do so.